Hey everyone, we're doing trigonometry review worksheet today, assignment 20. Since I can't be in the room with you to answer any questions you have, I thought I would just make a video going over all these problems. Okay? So, um, 1. Simplify. Secant squared theta minus tangent squared theta. Well, the simplifying that I'm suggesting here is not factoring the difference of squares, but instead going from two different trig functions into only one trig function. Now, this is Kukla's way of saying, does the student remember their Pythagorean identities? Remember, we know that secant squared theta equals 1 plus tangent squared theta. We also know that tangent squared theta equals secant squared theta minus 1. And then, biggest of all, if we subtracted tangent squared from both sides, we'd have secant squared theta minus tangent squared theta equals 1. And so this equals 1. That's very simplified. Most students don't remember this identity. Most students do this by saying, oh, well, I know that this is 1 plus tangent squared minus tangent squared. And so the tangent squareds cancel and we get 1. Okay? Problem number 2. Tangent theta minus secant theta cosecant theta. Huh. Well, I think it's going to be really useful for me, since I don't know what tangent is in terms of secants and cosecants, to just rewrite everything in terms of sines and cosines. All right, so I'm going to have sine theta over cosine theta minus 1 over cosine theta times 1 over sine theta. Now, I've got two fractions joined with subtraction, and my middle school math teacher said that I needed to make a common denominator here. So I have to multiply over here by sine theta over sine theta. Hey, don't do that, because that's wrong, right? You're trying to make this, and what you're doing is this, and that doesn't work. Don't be lazy about just saying, I'm going to multiply both over here by sine. No, it's sine over sine. Please make sure you do that. So on top now I have sine squared, I have minus 1, and on the bottom, sine theta cosine theta. All right, what is sine squared minus 1? Well, I know that 1 minus sine squared is cosine squared, but I have sine squared theta minus 1. What's that going to be? Well, if I okay, here's the way I want to think about it. Sine squared theta plus sine squared theta. I get 1 equals cosine squared theta plus sine squared theta. And subtract 1. I get 0 equals cosine squared theta plus sine squared theta minus 1. And now I move my cosine squared over here, equals sine squared theta minus 1. What does sine squared theta minus 1 equal? Negative cosine squared theta, all over sine theta cosine theta. At this point, I can cancel out a cosine, so I have negative cosine over sine. And so we know this that is going to be negative cotangent theta. This simplifies to negative cotangent. All right? And then what do we have? Number 3 says tangent squared theta times 1 minus cotangent squared theta. Well, 1 minus cotangent squared is cosecant squared times tangent squared. I know that tangent squared is sine squared over cosine squared. I know that cosecant squared is 1 over sine squared. These will cancel. I'll have 1 over cosine squared, which is secant squared. So this is secant squared theta. What an interesting way to write secant squared. All right, problem number 4. So these without a calculator problems are ones that we should be able to do pretty fast. 4 says the sine of 2 pi over 3. We know that's root 3 over 2, or we really should by this point. Cosine of 5 pi over 6. That's the x value at 5 pi over 6, which is negative root 3 over 2. 6 tangent of 3 pi over 4. I know that's negative 1, but if you're not sure, you could always think about it as the sine of 3 pi over 4 divided by the cosine of 3 pi over 4. This is 1, this is negative 1, and so I get negative 1. Problem number 7, sine of negative 2 pi over 3. Well, so negative 2 pi over 3, there's negative pi over 3. Looks like 5 pi over 3. There's negative 2 pi over 3. Looks like 4 pi over 3. So this is the same as the sine of 4 pi over 3. We also had talked about, both in trig and in an earlier video, that if I have this negative angle, I could add one period. The period for sine is 2 pi. If I add 2 pi to this, it gets me this one. I can go from a value I don't recognize to one that I do recognize, either by adding or subtracting 2 pi, or the period. So the sine of 4 pi over 3 is negative root 3 over 2. How about problem number 8? 8 says cosine negative pi over 3. Yeah, let's try that. Negative pi over 3 plus 2 pi is negative pi over 3 plus 6 pi over 3, or 5 pi over 3. So this problem looks exactly like 5 pi over 3. And 5 pi over 3, sure, I know what the cosine is there, is 1/2. And there's my sentence. 9. Tangent negative 3 pi over 4. Okay, well, the period for tangent isn't 2 pi. Period for tangent is pi. So if I took negative 3 pi over 4 and added pi to it, I would now have pi over 4. And the tangent of pi over 4 is 1. Let's just check that. Negative 3 pi over 4. There's negative 1 pi over 4. There's negative 2 pi over 4. There's negative 3 pi over 4. Well, it is 1, but it sure doesn't look like pi over 4. Over here is 5 pi over 4. Huh, interesting. Yeah, I like just counting it. I don't run into problems then. Okay, so the tangent of negative 3 pi over 4 is the same as sine of negative 3 pi over 4 over the cosine of negative 3 pi over 4. And so we get negative root 2 over 2 divided by negative root 2 over 2, and that will still be 1. So you've seen two ways to do that problem. 10. Sine inverse of negative 1/2. Remember, this doesn't ask just what angle. It asks what angle within the restriction. The restriction goes from negative pi over 2 to pi over 2. Our answer has to be within that range. Okay, so what angle within the restriction has an upness, or y value, of negative 1/2? Yeah, so that's not going to be 7 pi over 6, because 7 pi over 6 is bigger than pi over 2. That's not going to be 11 pi over 6, because 11 pi over 6 is bigger than pi over 2. That's going to be negative pi over 6, right? I can't get past pi over 2. So the only way to get to this place where I have an upness of negative 1/2 is if I go in that direction. That's why I have negative pi over 6. Okay, how about problem 11? 11 says sine inverse negative root 3 over 2. All right, so that's going to be negative pi over 3. I'm thinking about when is the y value negative root 3 over 2, but my answer can't be 5 pi over 3 or 4 pi over 3 because neither of those are within the restriction. I need something within the restriction from negative pi over 2 to pi over 2, where the sine value is negative root 3 over 2, and that happens here at negative pi over 3. Okay, what's next? 12. For 12, we know that the tangent of x equals negative 5/4. We know that x lives between pi and pi over 2. That means that this is a draw a triangle problem, and I'm drawing the triangle in quadrant 2 because my angle is somewhere between pi over 2 and pi. What do I know? I know negative 5/4. So that's 5, that's negative 4. Because tangent is opposite over adjacent. Now, if you try and do this, where you say, oh yeah, that's negative, goes with that 5, are you in quadrant 2? Are you meeting this condition? No, it can't be that. Your middle school teacher also tried to convince you that when you see this, it's identical to this, and even identical to that. So I'm just saying that this is this because I need it to be in quadrant 2. All right, what's the missing side? Square root of 25 plus 16 is 41. And what are we looking for in this problem? It says find the other trig functions of x. So we've got tangent. We know cotangent then would be negative 4 over 5. And what about sine? Well, sine is opposite over hypotenuse, 5 over root 41, or 5 root 41 over 41. Therefore, cosecant would be root 41 over 5. And what about cosine? Cosine is adjacent over hypotenuse, negative 4 over root 41, or negative 4 root 41 over 41. And therefore, secant is going to be root 41 over 4, and don't forget to have a negative on that. Okay, that's what problem 12 was looking for, the other 5 trig ratios, if you knew this about the angle and you know the angle lived there. All right, what's next? 13, we're solving on 0 to 2 pi. Okay, 0 to 2 pi. So 13 says 2 tangent x minus 1 equals 0. I know that tangent of x equals 1/2. Well, do you know when tangent equals 1/2? Because I sure as hell don't. I really don't. I don't know when tangent. I know when sine equals 1/2 or cosine equals 1/2. I don't know when tangent equals 1/2. So this is going to be with calculator. I mean, I could do this. I could take the tangent inverse of both sides. But that's only going to give me one answer. And when I think about the graph of tangent, from 0 to 2 pi, when does this tangent equation cross the line y equals 1/2? Well, twice, once here and once here. This one is tangent inverse 1/2. And this is one period away from it, so it's pi plus tangent inverse 1/2. Now, having students write answers like this is wicked old school. I mean, even older than me, they used to do that. So instead, this is a calculator question. I'm going to graph tangent, I'm going to graph 1/2, and what is it that I'm supposed to remember when I'm doing a trig graph on my calculator? I'm supposed to remember that the mode had better be in radians. So I'm going to graph tangent, tangent x, close parentheses, let's get rid of all this other stuff, and I'm going to graph 1/2. And my viewing window, let's change my viewing window, x min is 0, but x max is now going to be 2 pi according to this restriction. And I'm going to go up in steps of pi over 2. My y values, well, I want to include 1/2. So how about 0 to 1? 0 to 1. Graph. So I see 2 points of intersection. I can do second, calculate, intersect to find them. Remember, this is pi over 2, and I'm to the left of pi over 2. Pi over 2 is 1.57, so I want this number to be less than, maybe you can't see it. How about this? I want this number, this x coordinate of the cursor, to be less than 1.57. Okay, so I'm on the left side. I hit enter. Second curve, yes. The linear one, no, I don't want to guess. And so I end up with x equals 0.464. And then to find this other one, second calculate, intersect, I want to be over here, which looks bigger than pi. So I'm waiting for my x value to get bigger than pi. Almost there. Ah, look, there's the cursor. If I don't go far enough, it'll just find that point again. And I get x equals 3.605. Okay, those are the two answers. Any questions? I hope not. Okay. Oh, that light didn't help edify. No, this one. Yeah, well, I'm glad I narrated it. Okay. 14. 14 says 3 sine squared x minus 5 sine x plus 2 equals 0. So let's factor 3 sine x, 2, 1, minus, and plus equals 0. So I know sine x equals negative 1/3, and I know sine x equals 2. Well, sine x can never equal 2. We know from our sine graph that the highest y value is 1. So sine can never intersect the line at y equals 2. That's crazy. But sine can equal negative 1/3 on 0 to 2 pi in third quadrant and in fourth quadrant. So again, I can reach out for my calculator to help me. You really can't see it. What if I bring it up? No, that's even worse. Oh, almost good. There's this little spotlight I can try and find. Yeah, I'm going to get that up and just say I'm graphing sine in y1 and I'm graphing negative 1/3 in y2. My viewing window 0 to 2 pi is still good, but now 0 to 1 isn't any good. I need negative 1 to 1. Okay, graph. Remember, you've got to be in radians when you do these trig graphs. Okay, second, calculate, intersect. The first solution is 3.481. Second, calculate, intersect. The second solution is pretty close to 2 pi. Maybe it'll be 6. Maybe it'll be a little less than 6. Enter, enter, enter. And I get 5.943. 943, yeah. So those are the solutions that we come up with here. Okay, what about 15? Ooh, there's a 2x. So 15 says secant to the fourth 2x equals 4. Okay, so, the first thing I need to do is take the fourth root of each side. And when I take the fourth root of each side, this is pretty straightforward, but over here, because I took the even root of both sides, don't forget the plus or minus, I'd also probably rewrite this as 2 squared to the 1/4, and then raise a power to a power. So plus and minus 2/4 or 1/2, okay? And the reason I wanted to do that, because that's plus and minus root 2. Okay, that's what secant 2x is. So what's cosine 2x going to be? Well, that's plus and minus 1 over root 2. And if I rationalize here, I get root 2 over 2. Oh, I know root 2 over 2. So when is cosine equal to plus and minus root 2 over 2? And this says go around the unit circle twice, picking up solutions. So it looks like I'm picking up all of the pi over 4s, and I'm going to go around twice to do it. So what are those solutions? Well, we've got 2x equals pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4, 9 pi over 4, 11 pi over 4, 13 pi over 4. Did I go too far? There's one period. No, I need to go a little further. 15 pi over 4. Okay, that's what 2x equals. I need to know what x equals, so I'm going to divide everywhere here by 2 and get x equals pi over 8, 3 pi over 8, 5 pi over 8, 7 pi over 8, 9 pi over 8, 11 pi over 8, 13 pi over 8, and 15 pi over 8. Alrighty. Don't forget the plus and minus. Don't forget the plus and minus. Whenever you take an even root of both sides, you need that plus and minus, or else you're only going to have half of these answers. All right? 16, power reducing identities. We talked about that in a video. Definitely need to know your power reducing identities for next semester. So let's take a look at 16. We've got sine to the 4th x. That's the same as sine squared times sine squared. We know that sine squared is 1 minus cosine 2x over 2, and sine squared is 1 minus cosine 2x over 2. And so I'm going to FOIL on top, and I'm going to have 1 minus 2 cosine 2x's plus cosine squared 2x. Cosine times cosine makes cosine squared. No, I'm not multiplying those together. All over 4. In the video I did, I said I would split this up into 3 fractions now. But at this point, I recognize I still have a squared, so I need to use my power reducing identity again, and I need to replace this part with my cosine double angle. My cosine power reducing formula. Remember, when we use the power reducing identity, the power reduces from second to first, but what happens to the angle? The angle doubles. So in this problem, my next step would look like 1/4 minus 1/2 cosine 2x plus 1/4, and now my power reducing identity, 1 plus cosine, and this angle doubles, 4x all over 2. Okay, this gets split into 2 fractions. I need to distribute the 1/4, so let's make some room for those actions. 1/4 minus 1/2 cosine 2x plus 1/8 plus 1/8 cosine 4x. Okay, and I see some like terms to combine. So 3/8 minus 1/2 cosine 2x plus 1/8 cosine 4x. Okay, there's 16. 17. Cosine to the 4th 4x. Ooh, I better give myself some space for that. 17. Cosine to the 4th 4x is going to be cosine squared 4x times cosine squared 4x. So I'm going to use the power reducing identity here and here. And what happens to the angle when I do that? The angle doubles. So this becomes 1 plus cosine 8x over 2 times 1 plus cosine 8x over 2. When I FOIL, I get 1 plus 2 cosine 8x plus cosine squared 8x all over 4. I split that into 3 fractions. But then I see I have to do the power reducing identity one more time. So 1/4 plus 1/2 cosine 8x plus 1/4 times, what happens to this angle when I use the power reducing identity? It doubles, 16x over 2. I still need to split this into 2 fractions, and I need to distribute that 1/4. So let's go and do that. So now my problem looks like 1/4 plus 1/2 cosine 8x plus 1/8 plus 1/8 cosine 16x. Like terms, let's combine them. 3/8 plus 1/2 cosine 8x plus 1/8 cosine 16x. Okay? All right. Do we have any more power reducing? We have one more. Number 18 is a sine to the fourth 5x. Sine to the fourth 5x. Okay, so that's that's sine squared 5x times sine squared 5x. So when I use my my sine squared power reducing identity, I'm now going to have 1 minus cosine. What happens to the angle? The angle doubles. Over 2 times 1 minus cosine 10x over 2. I FOIL 2 cosine 10x plus cosine squared 10x over 2 over 2, over 4. So I see that cosine squared, which means I need to use power reducing again, so that angle is going to double. 1/4 minus 1/2 cosine 10x plus 1/4 times 1 plus cosine 20, or 20x, all over 2. So I need to split this into two fractions. I need to distribute the 1/4. I'll have a 1/8 plus 2/8, so I'll have 3/8 minus 1/2 cosine 10x plus 1/8 cosine 20x. All right, power reducing fun. No, not really, but we'll need it next semester. That's why we're doing it. Okay, problem 19 says graph y equals -2 sine x over 2 plus pi over 3 plus 5. Excellent. I'm graphing one period, so I'm going to set the argument x over 2 plus pi over 3 equal to 0, and x over 2 plus pi over 3 equal to 2 pi. So here I get x over 2 equals -pi over 3, or x equals -2 pi over 3. And here, 6 pi over 3 minus 1 pi over 3 is 5 pi over 3. And then when I multiply by 2, I have x equals 10 pi over 3. So I know where my period starts, and I know where my period ends, and what's halfway in between? Well, I add these and double that. I get 8 pi over 6, which is 4 pi over 3. Is that true? Well, the distance from 4 to 10 is 6. The distance from -2 to 4 is 6. So that's correct. Now I need to find my quarter points. Halfway between 4 and 10, that would be 14 over 6, or 7 pi over 3. And halfway between -2 and +4 is going to be 1 pi over 3. Okay, it's a negative sign graph, so it does start on the midline, but then it goes down, back up to its high point, and ends on the midline. So we draw in that graph. Don't forget to label this y equals 5. And now we're going to use the amplitude 2. The amplitude is not -2, the amplitude is 2, to go down 2 from 5. So this is pi over 3, 3. And to go up 2 from 5. 5 plus 2 is 7. So we'll have 7 pi over 3, 7 is that point. All right, there's our one period of sine, problem number 19. Problem 20. Graph a cosine. 1 equals 1/5 cosine 2 pi x minus pi over 4 minus 7/5. Okay, so cosine, I set the argument 2 pi x minus pi over 4 equal to 0, and 2 pi x minus pi over 4 equals 2 pi. I get 2 pi x equals pi over 4. If I divide by 2 pi on each side, I get 1/8 here, right? Because 1 over 2 pi, these cancel, 1 over 8. What about here? Well, this is 8 pi over 4 plus 1 pi over 4 gives me 9 pi over 4. And then when I divide by 2 pi, I'm going to have x equals 9/8 because the pi's cancel. Okay, so my graph starts at 1/8 and ends at 9/8. Halfway in between would be 5/8. Here's 3/8. I'm so used to writing those pi's. 7/8. And this is a positive cosine. We know positive cosine starts high, goes to its bottom, and then back up again. Don't forget to show me this concavity. Concavity is really important this year. We know that this is y equals -7/5. Our amplitude is 1/5, so I'm going to go up a fifth. This will be 1/8 -6/5. I'm going to go down a fifth. This is going to be 5/8 -8/5. And I'm going to go up a fifth, and so I get 9/8 -6/5. And there's my cosine graph. Okay, 21. Evaluate without a calculator. 21. Cosine inverse -1. Well, what angle within the restriction, and the restriction for cosine is 0 to pi, has an x value or overness of -1? Well, that's easy. That's pi. 22. Secant inverse -2. Yeah, I don't know from secant inverse, but I do know that cosine inverse would be -1/2. When within the restriction for cosine is the x value -1/2, that happens at 2 pi over 3. But wait. Oh yes, those are the same. Okay, 23. 23 says cosecant inverse 2√3 over 3. You know, this might be easier to look at if you unrationalized it or rationalized the numerator, because then you'd end up here. And you'd say, well, that means that sine inverse is √3 over 2. When within the restriction for sine, -pi over 2 to pi over 2, is the y value, √3 over 2, and that happens at pi over 3. 24. Tangent inverse -√3 over 1. Well, that's the same as sine inverse √3 over cosine inverse. No, I'm not going to do that. I'm going to say that's the same as that. And so I'm asking the question, when is sine this and cosine this? I guess I could do that. But I don't recognize those from my unit circle. Well, this one maybe, but this one no. So let's divide top and bottom by 2. Oh, and there's a negative here. Does the negative go here, or does the negative go here? It kind of matters. What's the restriction for inverse tan? -pi over 2 to pi over 2. So we're looking for an angle in there. Now, I know that that this one negative and this one positive, that would take place in quadrant 4, and that would be 5 pi over 3. But that's outside our restriction. So I'm going to have to put that negative here. And now I'm thinking about something in quadrant 2, and that's going to be 2 pi over 3. Oh no, that's also outside of this restriction. What can I do here? Well, remember that first one I got, that one that I said was 5 pi over 3? Yeah, but I'm going to come at it from the other direction. And so -pi over 3 is my answer. This is -pi over 3. Okay? It may not be okay, in which case you might want to ask some more questions about that. 25. We've got sine inverse of -√3 over 2. And so we're saying what angle within the restriction is -√3 over 2? Well, this can't be 4 pi over 3 or 5 pi over 3 because both of them are outside of the restriction. It has to be -pi over 3. That's the only time between -pi over 2 and pi over 2 where the y value will be -√3 over 2. 26. tangent inverse 0. That's 0. Come on, you know the tangent graph. What's that point in the middle? It's 0, 0. When the tangent value is 0, the angle is 0. So when the tangent value is 0, the angle must be 0. All right, 27. Cosine inverse of cosine of 0. Is this a situation where I can just cancel these out? Yes, I was given an angle, and that angle is within the restriction for inverse cosine, and so yes, I can just cancel these out. But let's say I forgot that. Let's figure this out. What is the cosine of 0? 1. And now we have inverse cosine of 1. What angle within the restriction has an x value of 1? It's not 2 pi because that's outside the restriction. So it is, though, 0. 0 degrees, 0 radians. Our answers are in radians. 28. Tangent inverse tangent 7 pi over 6. Well, this angle is outside of the restriction for inverse tangent. Remember, our inverse tangent is all about negative pi over 2 to pi over 2. That's bigger, much bigger. That's in third quadrant. Okay, so I have to go the long way. What's the tangent of 7 pi over 6? Well, that would be sine of 7 pi over 6 over cosine of 7 pi over 6. Sine of 7 pi over 6 is negative 1/2. Cosine of 7 pi over 6 is negative root 3 over 2. So I flip and multiply, and I get 1 over root 3, or root 3 over 3. Now I want to know what angle has 1 over root 3 as its sine and cosine. And again, I come to that place where I don't know, but if I do this, I can say, okay, the sine is supposed to be this, the cosine is supposed to be that. How about pi over 6? Yes, pi over 6 works great. Okay, and the pause I had just there was thinking about the problem this way, and we had negative 7 pi over 6 where we had negative over negative for positive, but one period away, pi away over here at pi over 6, the sine and cosine are positive as well. So I felt comfortable then with that. But I had to think about it for a minute. Okay. That was 28. There's only 2 problems left. 29. Sine inverse of 3. What angle has a y value of 3? Not possible, because the range on sine is negative 1 to 1. Sine never equals 3. And you could appeal to this problem graphically if you like as well. The graph of sine x has a maximum of 1, and that will never intersect the line y equals 3. Okay, problem 30. Explain why sine inverse of sine of 5 pi over 6 does not equal 5 pi over 6. And the answer is that the given angle is not within our restriction of negative pi over 2 to pi over 2. So I'm going to have to go through this the long way to figure out, all right, the sine of 5 pi over 6 is 1/2. What angle within the restriction has a y value of 1/2? And that's pi over 6. So my answer here is pi over 6, not 5 pi over 6. I hope this was helpful. I hope you're feeling more confident than you were on the first day of class with your trig and pre-cal knowledge, and that you feel pretty ready for this Chapter 1 test. I will say on the Chapter 1 test, you know, it's really just a measure of how solid your pre-cal and trig skills are. It's not a referendum on whether you can do calculus or not. we won't start doing calculus until chapter 2. This was all just sort of warming up legwork. And I think you'll see when we start calculus, yeah, it starts pretty easy. Um, don't forget your trig and pre-cal, though, when we start chapter 2. All right, study well, get sleep, review your notes, and let's have that test. Take care, everyone.